All right, so for this first one, we're going from 0 to 8 using 4 equal subintervals. So from 0 to 8 would be 8 units. Dividing that into 4 equal subintervals, what's going to be the length of each subinterval? They'll all be 2. So at first glance, it's like, oh, well, all I need to plug in is 0, 2, 4, 6, and 8. But if you want to do a midpoint sum, you also need the numbers in between. So you're going to need to start with 0, go to 8, and plug in all of them because you need the ones in between. For the sake of time, I have these written down here, so I'm going to just copy these over. But how would you get these numbers? Yeah, just plug them into the equation. So you're taking these and plugging them in for x right here, the 1/2 x squared plus 2. But I know some of you got through this. Are you getting the same numbers as me? You zoom in more. And I also think it helps to circle your subintervals. So your subintervals would be 0 to 2, 2 to 4, 4 to 6, and 6 to 8. Again, there's 4 of them. It said 4 equal subintervals. Now you asked about midpoint sum, so I'm going to jump straight to that one. The length of each subinterval is 2, and you would take the numbers in the middle of the subinterval. So for the first one from 0 to 2, you'd take the one in the middle, which would be 2.5. Plus, and then again, here's your next subinterval. The one in the middle would be 6.5, and then 14.5, and then 26.5. Please don't do anything to that. It is so much easier for me to grade if you just leave it alone. Left sum and right sum, same thing. The subinterval is 2. You would just take the numbers on the left and then the numbers on the right. Trapezoidal, what else do you need out front for the formula of a trapezoid? 1/2. So it would be 1/2 times 2, which I guess in the end, those would cancel. I'd like for you to write it so I can see you know the pattern. And then you would use the first one and the last one only once, and all the ones in the middle twice. So it would be 2 plus double the 4, plus double the 10, plus double the 20, plus the 34 just once. Or you could write all 4 trapezoids separately. That's an option, but that way is definitely shorter. Like all of them separately? Yeah, here, I'm not going to be able to fit it on here though. Let me pause this recording. All right, and again, for number 3, all you have to do is set it up. All you have to do is the setup. All right, number 7, anyone in particular? Or, oh, sorry, I thought this was 7, A, B, and C. Never mind, you said number 7. All right, antiderivative. You need a function that if you did the derivative, you would get sine. So like sine's the answer. Good, negative cosine. The derivative of cosine would be negative sine. So you need that negative in there. All right, minus, and then this would be x to the 5th, such that negative pi over 2 to pi. All I really want you to do is evaluate the trig. The rest of this you can totally just leave alone. All right, so we're going to do upper boundary minus lower boundary. Again, I think it helps if you set it up blank. So let's plug in pi. Cosine of pi, where is pi on your unit circle? To the left. Yeah, up, down, left, or right, it'd be on the left. The point -1, 0. Cosine is the x value, good, so that would be -1. So it would be -1. So that part would just be 1. Minus, and you're plugging in pi, so that would be pi to the 5th, whatever that is. You would just leave it. All right, now plugging in negative pi over 2. Negative pi over 2 means that you're rotating backwards. So if you start here and rotate backwards, negative pi over 2 would be right here, 0, -1. Are you coming with me on that? Like we rotated backwards. Cosine is the x value, so that would be 0. Minus negative pi over 2 to the 5th. And then please don't do anything to that. I do want you to evaluate the trig, but the rest of that, please just leave it on. I realize it looks like a disaster, but that's fine. We're used to our answers being a disaster, right? All right, what else? Again, I want to do as many as I can for you. Yeah. So this one, antiderivative would be ln of x from 1 to e to the 7th. We're going to do upper boundary minus lower boundary. Yeah, this one I would want you to evaluate, like simplify it down, because you can. If you plug in e to the 7th, you would have ln e to the 7th and then minus ln of 1. This would just be 7, right? And then ln of 1 is 0. So you'd actually just end up with 7. So I do want you to evaluate that one because it comes out nice. When you do 4, 5, and 6, you're not going to evaluate them because those are indefinite integrals. What would you have to put at the end of all of these? Make sure you put a plus c for every single one of those, okay? Do you want to maybe do this one because it involves a negative? Let's rewrite that first. Good, perfect. The negatives are hard. Well, first of all, negatives are just always hard, but when you add 1, you're making it less negative. So it would be x to the what? -2, good, -2nd. We're struggling on how to say that. So then you'd want a -1/2 out front. There's already a 4 there. So -1/2 times 4 would be -2. And then you can always check your work. If you were to do the derivative of this, you would get this. If you multiply this down, you get 4, right? And then subtract 1, you would get -3. Anyway, you can always check your work. And I do want you to fix the negative exponent. Don't leave negative exponents in there. It would be -2 over x squared plus c. This one, I like this one. We'll just go ahead and do this because it'll only take a second. E to the x plus 7x plus c. They're not all going to be really hard. Do you know what I mean? It's like a collection of easy, medium, and hard problems. So like some of them are tough, but then you'll get like an easier one. The one that mirrors exactly what's on your quiz is the one like this one. So we'll do that one. All right, average value would be 1 over 4 minus 1, integral from 1 to 4 of all of that. I think that's the one that I... Yeah. All right, so that fraction out front is a 1/3. This antiderivative, so for the x, it would be 1/2 x squared, but there's a 3 there. So it'll be 3/2 x squared plus what? What would this antiderivative be? 1/3 x cubed, such that 1 to 4. Put the 1/3 out front, and it's going to be upper boundary minus lower boundary. Again, I strongly recommend you just write it out blank like that. I think it helps with not getting confused with what goes where. So we're going to plug in 4. 4 squared is 16. 16 times 3 would be 48. Divided by 2 be 24. Again, I think you should simplify a little bit because otherwise you'd have to write 3/2 parenthesis 4 close parenthesis squared. And if you mess up a parenthesis, it's not right anymore. All right, plus 4 cubed is 64, so that'd be 64 thirds. And then if you plug in 1, you will have 3/2 plus 1/3.